Hello.
Hello.
Hello. Hello.
Hi, I'm Mr. McIntosh, and I'm here to give you an introduction today to scientific measurements. In science, we use what is commonly called the metric system, also known as the SI system, and SI stands for Société Internationale, okay? Literally Société Internationale d'Unis, which means the International Society of Units in English, okay? And the reason for that is because a lot of this early work was done in France. It was a problem measuring things around the world because sometimes maybe the word foot came from the length of a king's foot or something like that, and then when you got a new king, his foot wasn't the same size, and so all the measurements got all weird. So some scientists decided we better have one way of measuring stuff. So they had a big meeting in France some time ago, and they thought about how can we come up with these standard units. And then one thought that they had was to set up a pendulum and get it swinging, and they would call how far it would swing in 1 second would be the distance of a meter. And that was a pretty good idea, except that pendulums swing different distances at different places on the Earth because the gravity is not all the same, okay? So what ultimately they decided was to agree upon something that everybody pretty much knew how to measure, and that was the Earth. Voila. So they were in France, so this line right here is pretty close. There's France on the globe, and they made an imaginary line from the pole right through Paris down to the equator. And they divided that into 10 million equal pieces and decided that we would call that a meter. And it's changed a little bit since then, but that is reasonably close to today's current definition of a meter. Now, I'd like to now refer you over to a chart over here that talks about some of the basic measurements that we have for the metric system, as we'll refer to it, or the SI system. So I'd like to refer you now to this chart that we have here, and at any time you can pause it and copy this down. We have the type of measurement in this column, the unit of measurement in the SI system in this column, the instrument we use to measure it here, and then some visual aids to give you some sense for how big these units are. So in the SI system, the unit of length is the meter with the abbreviation small m, and we use our trusty meter stick, or sometimes a smaller metric ruler to make those measurements. And that is about the height of a door handle on a door, roughly. Okay? There are two kinds of volume, and volume is the amount of space an object takes up. Okay, I repeat, the amount of space it takes up, three-dimensional space. Right? Two kinds, there's liquid and gas volume, and those are measured in this thing called the liter. All right? And we use our handy-dandy graduated cylinder to measure liquid volumes. We don't use beakers because the graduations on beakers are not all that accurate, but these are super-duper accurate, so we use these to measure liquid volumes. Gases volumes are measured some other way. Also, we can have solid volumes like, for example, this box-like thing right here. It's got a length, a width, and a height, three-dimensional shape. If we measure all three dimensions, multiply them together, we get cubic centimeters for the volume of this shape. We use a ruler for that. And to get some idea of how big a liter is, you know, you got your big 2-liter bottle of soda. Well, it's about half of one of those. Mass. This is the amount of matter in an object. The standard unit is kind of odd. It's the kilogram. You might expect it to be the gram, but no. In the SI system, it's the kilogram, which is about 2.2 pounds, roughly. Okay? And we use a balance, also sometimes called a scale, to measure the mass of objects. All right? And I have a scale right here. Ta-da! This is the classic triple beam balance. Often we use electronic ones, such as this one, which has a digital readout on it, a little easier to use. Okay? Those are for measuring mass, which is what? That's right, the amount of matter in an object. And a paper clip, for example, weighs about 1 gram. So I wonder how many paper clips it would take to make a kilogram. Finally, the other unit we're going to talk about today is temperature, which is a measure of the thermal energy inside anything. Gas, liquid, solid, your face, your teeth, whatever. It makes no difference. Okay? And this is measured in degrees Celsius, which is a degree symbol with a capital C. Okay? Not to be confused with degrees centigrade, which is the same thing, but that unit is not used anymore. Okay? And we use a thermometer to do that. There are lots of different kinds of thermometers. There are digital ones, there are ones with liquids in them that read up, but they just tell you what the temperature is. And it's very important to know these two facts, that water freezes at 0 degrees C, and it boils at 100 degrees C. In fact, that is how the degrees C system was made. They decided we're going to freeze water and call that 0 degrees. We're going to boil it and call that 100 degrees C. Okay? So that is your introduction to scientific measurements.
Hey guys, this is really important. You better write it down. Alright guys, today we're going to look at how to convert within the metric system. I'm Mrs. Hanson and I'm going to expand off of the chart when you learn the common measurements from Mr. McIntosh. Okay, so looking at the common units, I like to think of the base units as home units. So right in the center of my paper, I would draw a little house. And this is what I call home. I'm going to tell you that home has the value of the number 1. And the reason why I chose home has the value of 1, because I live there and I'm number 1 in my family. Who also lives in my home with me? My sister Meter, my brother Graham, and my grandma Leader. We are all number 1 at home. In our house that we live on a hill. And anybody who lives in a neighborhood on a hill or a cul-de-sac or regular street, you have neighbors. And I have 3 neighbors to the left of me and 3 neighbors to the right of me. All of my neighbors have a name, and I'm going to start at the top of the hill. The very top of the hill, my favorite neighbor, their name are the Kilos. Next door to the Kilos live the Hectos. Next door to Hecto and right next to my house live the Decas. As I proceed down the hillway, I have my other friends who lived going towards the bottom of the hill. Desi lives on the other side of me. Senti lives next to Desi. And at the very bottom of the hill is our friend Millie. Now, as you can see, I have a value of 1 in the center of the hill where I live. As we go up the hill or down the hill, our values change. And they're all on the base number of 10. Moving up the hill, the value changes by a multiple of 10. One times 10 would be 10. Deca has a value of 10. 10 times 10 is 100. Hecto has a value of 100. 100 times 10 is 1,000. Kilo has a value of 1,000. Just as we multiply going up the hill, going down the hill we're going to get smaller because we're going down. So we're going to divide by 10. 1 divided by 10 is 1/10. Desi is 1/10. Senti divided by 10, 100. And Millie divided by 10 has a value of 1,000.
Freeze the frame!
Now, what does that mean to you? That means the values that we have living on our hill. Have you guys heard the old, what's that called?
Mnemonic.
Mnemonic, thank you. The old mnemonic, King Henry died at home drinking chocolate milk. That mnemonic is to help you remember the order. Kilo, hecto, deca, home, deci, centi, milli. Why this is important is as you were trying to convert these values in the metric system, if you know which direction you are going up and down the hill, it is super easy. All you have to do is move a decimal point. I want to know the equivalent value of something from meters to centimeters. we can measure with the meter stick and get the same value using a centimeter. So let's pretend I measured the length from where I'm standing to the doorway down there. And I'm going to say I measured it. It is 5 meters. I'm going to ask, if it's 5 meters to the doorway, how many centimeters would that be? Very easy to figure out. I don't have to take out my ruler and measure in centimeters. I can convert from meters to centimeters. The easiest way to do this, first of all, take your number. 5 is a whole number. Where does the decimal go after a whole number? At the end of the number. Now I'm going to move my decimal 2 spaces. I'm going down to centi, and centi lives 2 houses over, so I must move the decimal 2 places. 1, 2. 1, 2. Fill in the slots as placeholder, zeros for placeholders, and I end up with 500 centimeters. 5 meters is the same thing as 500 centimeters. That was super easy. Now I want to know, if I took meters, how many kilometers it is to go from here to the doorway. Well, I don't have a kilometer stick. I don't know about you. So I can't really measure that. But I can convert it. If I have 5, it's a whole number. I'm going to go up the hill. Which direction am I going? I'm going to the left. I'm going to move my decimal the same direction I'm going. 1, 2, 3 place values. 1, 2, 3. 0.005 kilometers is the same thing as 5 meters.
You get it?
Hello, I'm Mr. Tippy, and I'm going to be doing a more mathematical way of doing unit conversions. So this is unit conversions with what we call T-tables. And the reason it's a T-table is it kind of looks like a T, a bunch of T's put together. So to start off, the thing that you'll need to know is that we have our different home bases equal different things. So the first 3 are ones that you should know. And go ahead and write these down if you haven't already. So we have 1 kilometer, or 1 kilo equals 1,000 home bases. And that home base is what we talked about with the gram, or the liter, or the meter. Then we have 1 home base is going to equal 100 centi, or 1 home base equals 1,000 milli. So these first 3 are ones that you should know. If you know those, you can do any unit conversion that we're going to be giving you.
Now would be a really good time to write that down.
Now, the bonus one that you should probably know is going to be that 1 centi equals 10 milli. And that can just make things easier. You don't have to know it, but it's going to make things easier for you. So to start us off, what we're going to be doing is more mathematical, and so we're going to have a numerator and a denominator. So we're going to draw a line, and we've got our numerator and our denominator. And so we're always going to start off with what we know. So let's say that I'm going to go on a 3-kilometer race. So I've got a 3K. So it's 3 kilometers. And I'm trying to figure out how many meters am I running, since I actually have a meter stick and I know how far that is. So how many meters is that? Well, I'm going to start off with my kilometers on top in the numerator. So I've got 3 kilometers. 3 kilometers. Now, I'm just going to draw a line right there. And so I've got 3 kilometers. Now, anything that's in the denominator that's the same unit as the numerator, I can cross them out. So since I know that there's 1,000 base units in 1 kilometer, I'm going to put my kilometers on the bottom. So let's see here, 1 kilometer. And how many kilometers, or how many meters are in a kilometer? Well, there's 1,000. So I'm going to put 1,000 meters. Now, from here I can see that my kilometers are up here in the numerator, my kilometers are in the denominator, so all I'm going to do is just cross them out and I don't have to worry about them anymore. So I've got, and that's the unit that I'm looking for. Right here I've got meters, right here I've got meters, so I'm good to go. So now I'm going to rewrite the problem so that I I know exactly what I'm working with. So I've got 3, I'll move that over here. And everything that's on top, you're going to multiply by each other. So I've got 3 times 1,000. And I don't want to forget my unit of a meter. And then how many is on the bottom? That's just 1. And there's no unit with that, so it's okay. Now, 3 times 1,000. 3 times 1,000. If I wanted to do this longhand, I could, so that'd be 1,000 times 3. I get 0, 0, 0, 3. So there's 3,000. So there's 3,000 meters in 3 kilometers. Okay, so that's the first one. That's just the first one to do. Now, sometimes they're going to have more steps than that. Let's look at, I'm going to go from centimeters to meters. So let's say I have 526 centimeters, and I'm trying to figure out how many meters is that. So I'm going to put a question mark for meters. So I'm starting off in my numerator, so I draw the line, and I've got 526, and that's centimeters, and I draw my line. Now, I'm trying to think here. 526, I don't need to worry about that number, I'm just looking at the centimeters. So centimeters, how many meters are in a centimeter, how many centimeters are in a meter? I can just look over here, and I see there's 100 centimeters in 1 meter. So, I put my centimeters on the bottom, I put my meters on top, and there's 100 centimeters. So 100 centi in 1 meter. And from there, oh, I have exactly what I'm looking for, And these guys cross out because centimeters on top, centimeters on bottom. So I go 526 divided by 100, and I got to remember my units. So I've got 526 divided by 100. So I can either do that long-handed, or since I've got zeros, I can cross these out and move the decimal place over, And I've got 5.26 meters. Okay, so I've got 5.26 meters, or 526 divided by 100 is going to give me 5.26. So we have one where we have the numerator and one with the denominator. Let's go ahead and look at liters now. So I'm going to do 200 milliliters. So I've got 200 milliliters, and before I do this, what I want you to do is I'm trying to find liters. Go ahead and pause right now, and I want you to try and figure this out on your own. Okay? So pause me, I'll make a funny face and pause right then. Okay, so you've paused. Now, the first thing that you did, now that you've worked this out on your own, what's the first thing you did? You created your t-table. So you have your line, and you're looking, okay, so I've got 200 milliliters. That's the first thing that you're going to work out. Draw the line. Now, I've got milliliters, and I'm trying to go from milliliters to liters. So, my milliliters goes down in my denominator, and I've got liters on top. So these are going to cross out right away. And we're thinking, how many millis are in the base unit? So we can remember over here, there's 1,000 milli in 1 base, like so. Okay, so I've got 1,000 millis in 1 base, in 1 liter. And so I'm going to rewrite this over here. So I've got 200, and my unit is only a liter now, divided by 1,000. So 200 divided by 1,000, that is actually going to equal 0.2 liters. So I've got 200 milliliters, that's only going to be 0.2 liters, and that's the answer for that one. So, you've done that one on your own. Now we're going to get into some tricky things, because we can either do a quick conversion or we can take multiple steps. Let's take the multiple steps first. So what we're going to do is we're going to try and go from millimeters to centimeters. So let's start off with, I don't know, my favorite number is 8. So I'm going to start off with 888 millimeters. So I've got millimeters. And I'm trying to figure out how many centimeters that is. So my question is, how many centimeters are in 888 millimeters? So think about it. What is the first thing that I'm going to put down here? I've drawn my line, my T, and on the top of the line I've got my numerator, and what's going to go there? You're right, it's the 888 millimeters. Now let's just suppose that you couldn't remember how many centimeters there are in a millimeter, how many millimeters there are in a centimeter. But you do know your base. So you're like, okay, I know that I can go from meters down to millimeters. And you're like, okay, I know that there's 1,000 millimeters in 1 meter. Well, you're back to your meters. And you also know, because you memorize this over here, or you have it written down, that you can also go from meters to centimeters. So these millimeters cross out, and you can go from meters to centimeters. So you're like, there's my 1 meter, and wait, here's my centimeter. And I know that there's, help me out here. If you need to talk to the screen, you can. There's 100, exactly. So there's 100 centimeters in 1 meter. So 100 oh, and my meters cross out again. And then I'm going to rewrite the whole equation. So I've got 888, and my units, since my units have been crossing out, if I want, I could cross them or just erase them. So I'm only left with centimeters. 888 times 100 divided by, oh, and I've got the 1,000 down here, divided by 1,000. So if I want to, I could go ahead and work out the top and multiply everything out on the top and then multiply everything out on the bottom. I've only got one thing here. So that's going to be, let's see here, I'm going to add 2 zeros. So 88800 centimeters over 1,000. And then that's going to equal, it's going to be 88.8 centimeters. Okay. So, with that being said, this is the way that we can do it in several steps, and that's fine. We can do things in several steps. Or, since you guys know that there's 1 centi in 10 millis, what you can do is just do it in one step, and you know what? I'll let you guys do that one on your homework by yourself. And at the beginning of next class, all of your teachers are going to come by and see if you could do it in just one step. Okay? So you're going to try and do it in just one step and show us all how you did it, and we'll be ready to check it, and that will be a check to see how well you know this. Okay? So, with that being said, we're done.
Isn't that the crazy coolest thing you've ever seen?